Okay, now we'll be testing the double check valve assembly. Again, I am using a Midwest 830 gauge because all the valves are clearly identifiable. This is our Watts 007M1 QT. It's a 1-inch double check. The flow is moving in this direction. You can see by the arrow here. Test cocks go 1, 2, 3, 4. First thing we're going to do is always notify the customer, identify, inspect, and observe anything out of the ordinary of the assembly. After that, we will flush the assembly. There is no particular order when flushing this. My test adapters are already installed. So all my test cocks have been flushed. All my gauges are closed. I have my high side gauge hose right here. My bleed valve arrangement here. And I actually have two. Here's another one. The way these bleed valve arrangements work is they attach directly to the high side test cock, and then the high side hose attaches directly to that. We will not be using this unless that number 1 shutoff valve is leaking. So after we flush, we're going to attach our high side hose to the front side of check valve number 1. And we will pressurize that hose, establishing pressure on our gauge. We will bleed it off, at which time we'll record our line pressure, which is roughly 98 psi. At this point, we will add one more item. It's called a sight tube. And what the sight tube will do is actually bring the water level up. The center line of our gauge is where we would like to have it. Once we attach it, we will fill it. Then we'll cut it back off. Now we're completely set up. This process, we would shut off valve number 2 off, but since it was off when I arrived, I am going to put that in my documents in my notes section or my comment section of my test sheet. I will be, however, cutting off shut off valve number 1. Once I have isolated the assembly, what I'm going to do is remove all the pressure from the back side of check valve number 1, measuring simply how much water the check valve held in front of it. So that's what we'll do. If the water continues to flow out of the sight tube while testing, that's an indicator that shutoff valve number 1 is leaking. However, it did not flow out, it stopped. The needle on our gauge is properly holding roughly 2.0 psid, so the check valve is holding 2.0 or 2 pounds of pressure on the front side of that check. So now we will close our test cocks. We will remove our sight tube. We'll remove our hose. We will re-energize the assembly. Attach our hose to test cock number 3, which is now the high side of check valve number 2. Slowly pressurize it and bleed it off. Now we will take our sight tube, we will attach it to test cock number 4. Then we will fill it. Again, trying to maintain that center line. Once we have our sight tube filled, we can now isolate the assembly once again. And now we will remove the pressure from the back side of check valve 2. At the same time, we're going to be watching the water coming out of the sight tube. If it recedes, that tells us shutoff valve number 2 is leaking with flow downstream. If it continues to come out, that is telling us shutoff valve number 2 is leaking with back pressure downstream. So let's see. It appears neither one has occurred. The water came out and it stopped flowing. It did not recede, it did not continue to flow out. That would tell us that shutoff valve number 2 is working properly. Also, on our gauge, our needle is holding at 2.0. That would also tell us that the check valve is working properly. We would record that value. So in this scenario, both check valves actually held roughly at 2.0 psid. It also tells us this assembly does pass. and it's a good working assembly. So we'll close our test cocks, move our sight tube, remove our high side hose, repressurize the assembly, open our valves for transport, and we have completed the test. If you note, I did not open shutoff valve number 2 back up because it was off when I arrived.